Well, hi guys and gals. Here we are. I'm going to do a quick one today. Boy, oh boy, I got up this morning and checked my email, and I was shocked. The number of responses I got from part one and part two of this project. Apparently, I hit a nerve there. I got a lot of very nice people asking some great questions. Apparently, some of you still remember or have jotted down my email from my website, bobsamerica.com. And had a bunch of emails there, and I had a few comments on YouTube, and all very nice, very well. So, yeah, let's proceed with this puppy. Um, Here's what I've done so far today. I've got to go back to the computer and finish laying out the front panel, and then as soon as that's done, I'll machine the panel, and then I'm gonna machine the chassis, the gutless wonder. Compared to some of my other things, this thing is pretty empty. But I just want to bring you up to date, and thanks for all the questions. I hope I could answer them here. That's why I like YouTube better than the websites, is you get to talk to people. The website, you just read the text and then you walk away, probably knowing less than or having more questions than when you first went in. So okay, we're gonna have a big healthy power supply. Only because we want to work down into the low amp range of a system. You never want to push a supply to the edge where you're going to start getting ripple and noise and hash and all that. A real clean, I think I said this last time, 9-volt regulated power supply. That's the 9 volts that is going to drive the BAT 112s for actors. I want that very clean, so it is. I'm regulating down from 14 volts to 9 volts, so we're down below the ripple level and all that. This thing under load, I tested. There's not much of a load because we're running the preamp there, which is 15 mils or 20 mils, something like that, and that thing, which is like, I don't know, 1 or 2 or 3 milliamps. And of course, well, anything you do on RF, you want clean power. This thing here has been tested to, where's my notes over here? The output here at 9 volts is about 1.5, 2 milliamps of ripple or noise on the scope from 9 volts, 1 or 2 mils. I'm running into a pi network here from the power supply, cap input pi. The output of that at 20, where did I do that? 25 mils. I really went up on the current draw. 25 mils is sub millivolt ripple and noise. Let me say that again. From 9 volts on the 9 volt VCC, the B plus, we are looking at less than 1 millivolt of things you don't want. That's clean. That's really clean. And obviously, no switching power supplies allowed anywhere when you're dealing with AM or single sideband. We just don't do that. This guy you've seen before, it's the BAT arrangement. Very simple, in, out, and a biasing resistor. And the preamp, that preamp is fixed right now for 15 dB. It's about 7 to 1. Which should bring the ferrite rod level up to about that of a good outdoor antenna. A big, long, high outdoor antenna. And that's what some of my tests showed with the 160 dipole out there, or long wire rather. Excuse me. It was dusty down here. So the 15 dB makes up for the 7 to 1 in signal loss, but the noise is absolutely gorgeously low. I may adjust it. I can adjust down in, get the pointer. here and here, change those values, I can get this up near 30 dB. I may go from 15, which I like as a standard. That's a good figure for broadcast, RF input work. I may go to 20 or 25. I don't know. That'll be empirical, and I can figure it out. As a matter of fact, what I'm going to do probably is put some edge connectors here and here with shorting strips on them. So instead of any soldering, you could just put the shorting strip on or off and attenuate or increase the gain. And I'll arrive at that empirically, see what works the best. More is not better. I've said that before. You get too much more, and you end up overloading the stupid receiver. And here's the controls. Input level, drive level, and gain. Gain max 15, naturally. When we go to 0, it's actually unity gain, not 0. Unity gain meaning that we've got a gain of 1 in the preamp instead of a gain of 0. Oh, boy. I better turn on the air purifier down here. It's getting into my sinuses now. Here's the tuning pot for the BAT varactors. Guys, I got to tell you, this thing, I still will probably use the air variable mechanical capacitors in the future. Don't write me bad stuff. Stop it. Stop it right now. But doing this, getting your capacitance electronically, man, I got to tell you, that puppy works. This thing is so sharp. It's on the Q of this circuit now with the Ferrite rod, and this circuit is so sharp you almost need a vernier drive to turn the pot. And I'm only covering like 1.8, from 400 kilohertz up to almost 2 megs. So let's call it it's less than 2 megs, 1.5 megs or something. Effective coverage across the full rotation of this pot, and that is sharp. It's a little bit of a pain to tune, not much. It makes you happy when you see the peak come and go so fast because you missed it. But the Q's high, and that should make you happy. Again, this is going to be a gutless wonder because, that's it. I did find out there are some grounding things we got to play with, and I'm going to have switches out here on the front panel. Whether we want to do common ground, I thought it was necessary for the Ferrite to have it common ground with everything in the system, and I found out that isn't always the case. Sometimes it wants to be a balanced input. You're also going to notice that on the power supply, let's see if we can show it here. There's a Ferrite choke coming off the power supply. Of course, we go into the pi filter. There's going to be another Ferrite choke here. I've got one. See if you can see it. Right there on the varactor board. I've got one on the preamp board. That's because we don't want local pickup. We've got wires and conductors running around in here as short as they may be. But the AM signals are in the air. There it goes again. Sorry. I don't know. Maybe I shouldn't have run the vacuum before. Stirred up all of this stuff down here. So local pickup's a problem. Even if this were in a metal case, I'm not so sure I'd be happy with. The last one I built, it was in a steel case. If I just touched it with my hand, the capacity from my body touching, get this, a fully isolated shielded steel case, and the capacity from my body would make the meter jump a little bit. So the answer is just isolate every module with Ferrite on the DC feed. The signal lines are all going to be coax and grounded properly. But we're going to have the switches, so you can common ground or not the varactor. You can common ground or not the feed from the Ferrite. And let me get to that because I'm really getting yucky here, and I got to make this a little shorter. Hang on. All right, that wasn't so bad, right? All right, I had some comments about things I did here mechanically, and let's see if we can get this in focus nice. I did take out the hose clamp, only because I wanted it to get 360 rotation or close to it. That was limiting me to, I was losing 90 degrees. So I was getting about 270 degrees. What I did is cut a piece of felt. So there's a felt washer in here. Here's the plastic washer. I found a spring. I don't know what that's from. But it was in the spring box, so I found one. I cut a new collar here. And I put, I've got a number 4 screw sticking out. So now you don't have, the turning limit isn't the big knob on the hose clamp. Now it's just a pin. So I get about 3 degrees or 4 degrees short of a full 360 on the rotation. The spring, instead of forcing the collar up against the washer here and relying on the felt to give you friction, the spring is a much better idea. Glad I thought of it. All right. Up here on top, same thing. If you notice, go to there. And, whoops, this is one-handed operation there. All the way around again. Why? Well, here's one thing. This isn't a twin coil Ferrite. As you recall from the other videos, the sensing thing is in here, and then the pickup coil's here. This is not a figure 8 pattern. It's lopsided. So if I have a signal coming in from here in this direction, which let's say that's New York for me right now, coming in here, if I were to rotate this 180, you would think it'd be the same, but it ain't. So, what else? Of course, you know, the field here, instead of being in a magnetic loop that does this and loops over the top, it's probably something that goes like this and then down and then almost like, I don't know, like the number 6 instead of a figure 8. So, how do you beat that? Well, you could do the twin coil. I'm not going to get into all that stuff. That's another discussion. Just as somebody had mentioned, maybe, and thank you for the comment, that we should provide not only azimuth but angular so that I could tip this thing up and change the polarity from horizontal to vertical. I have a fixture for that. I'm looking right at it. I'm not going to show it to you because that'll be the next project, so let's not talk about it. What I'm going to do is the feed from here to the front panel, I'm going to put a polarity reversing switch. How's that, huh? Pretty smart. Old Bob, he's so stupid after all. What that does is that will change this lopsided lump here to a lopsided lump here. And hopefully, you know, the currents induced into the actual resonant choke here, the inductor here, will be reversed, and that will affect this. Now, I may do it, I think, at the pickup side. Doesn't matter. You reverse one, its relationship to the other is backwards, so it doesn't matter. I'll probably do it on the pickup side, which is a very low impedance end. Run it through a polarity reversing switch. I'll have the ground select switch here, so we can have common ground or balanced ground, independent ground. So that'll give us both of those options. Now, a lot of that depends on your radio. Is the chassis on your radio plugged into the wall? Because if it is, and you have a 3-wire plug, there's another ground loop. Think about that. That could affect everything. Don't forget, the feed line to your radio, 99% of the time, is a coax, and it's unbalanced. So, a lot of people don't realize that, once you're done with the antenna, that's the source, you're done. No, you're not done. Because the coax is feeding the radio, go right to the common ground on the radio. and how that common ground is connected to earth ground or to the world, all could change everything. It means everything. It will change everything. All right, so that's how we did here mechanically, and you can see now that it's spring-loaded, you could actually, what are people going to do? Oh, Bob made a RDF. Use this for the handle. Let's pick it up and walk around with it. Well, now you can. I don't want you to do it, but you can. That's pretty rugged. I put some Glipto on there. They're going to be moving, so I don't want the nuts and bolts all loosening up and everything. But there you are, PVC from your local store, and some long number 4 screws, and a little bit of felt off of whatever the felt was from. Then I mounted the connector board here. The idea is to keep those are very flexible silicone wires here. And I wanted to keep those away from the screws so they don't get pinched. So now we have this little doodad here that you can see it. Just kind of guides the wires and keeps them from flopping in indiscriminate places. And of course, they're so you take the cover off and work on the unit. That's why we've got plugs. So when you pull the cover off, you don't yank the wires out of the Ferrite bar. Just pull the plugs out, and you can walk away with the cover. Okay, real long again. Bob yaks. Okay. Well, it's cold out, and I'm bored, and I'm stuck in the shop, so it's nice to have friends. I want you guys to stay safe. Keep the questions and comments coming, and any ideas, we'll entertain them. I think version number 2 of this is going to be a little more exciting. And I might put I might build one like this with the gimbaled mount, as one of my YouTube friends has suggested. Just read the comments, and you'll, from part 2, and you'll see those comments about that. It'd be kind of nice to be able to lay this up like that, and see what happens with polarity reverse, broadcast polarity. So, all right, there you go. Bob N1KPR, YouTube, and bobsamerica.com, and N1KPR at arrl.net. If you still use the old email, tried, true, trusty emails. See you later. Bye-bye, and thanks for looking.